BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers.
My name, as he said, is Stephan Borosh. Today I'm presenting Digital Canaries and Coal Mines. I am a fill-in today, so thank you for showing up. This is kind of last minute for me. Hopefully you'll enjoy the content. This is kind of a rip from my latest blog post. So I didn't really have anything prepared, so I was up last night, half asleep, kind of putting these slides together. So it is kind of written like a how-to, but if you need to, I've got links in here that refer to the blog post in its entirety. So thank you for coming. Who am I? On Twitter I go by 424F424F. That is actually Bobo because I got that call sign in Afghanistan. But I go by Reverse Shell as my hacker handle. I have a Medium account where all my blog posts get posted. I also get cross-posted on the Spider Labs TrustWave account. And GitHub, which has a lot of terrible code that I write. Red Teamer, penetration tester. I work for TrustWave Spider Labs, the government solutions branch. I also work for TrustWave, the parent company. So I do commercial testing and government testing as well. And again, I'm a terrible coder. If you want to check out all my terrible code, it is on GitHub. So what is this talk about? This talk is about fooling adversaries who perform enumeration in your network and then attempt to do lateral movement by providing them with false information and detecting them at certain choke points or detection points. How we do that with DNS Canary enumeration. So we've got server level at the domain controller or DNS server with DNS Analytical Logging and Silk ETW, which is a great tool written out of FireEye. And Sysmon. Sysmon's version 10 and above, latest versions allow for DNS collection at the endpoint. So we'll talk about that. I wrote, I ported a bit of SMB server from Impacket and implemented a SAMR server which listens for enumeration. So when an adversary comes into the network and wants to say, well, who's local administrator on this machine? They do a query to the SAMR service, and then we respond with fake data and then alert on that query. So this is derived from my blog post, as I said. It's more of a how-to, but I'm going to skip some of the how-to for this, so hopefully I come in on time. So a fundamental part of any network is the domain name service. Adversaries at some point will probably need to interact with the domain name service within an organization. So what that looks like is when they LS or remote file share, that host name has to get looked up in DNS, and you see the standard query in a little Wireshark down there. So as attackers move through your network, they're going to have to interact with DNS some way, whether that's pinging or LSing or just querying for servers and services. It's going to happen. So it's a great place to detect them. Since we control Active Directory and DNS, we can control what the adversary sees, right? So as a domain administrator or as a network administrator, this is a great spot for us to introduce fake stuff. So I'm not so fond of the word honeypot, but like honey tokens, honey accounts, whatever, honey computer accounts, we can add to Active Directory, where most people aren't supposed to be querying that stuff. When you see it queried in the network, it's a great place to alert on. So in the early days of coal mining, miners would place a little canary in the shaft of the coal mine, which would allow them to detect noxious gases in the coal mine. So that's what we're going to kind of do here using HELK, Silk ETW, and DNS logging. So this is a bit of a two-part. So the first part we're going to talk about is the server side, detecting from the domain controller or DNS server. And then we're going to switch to doing host-based detection. So this is this is a little bit out of my realm. So I'm a red teamer, an offensive person, and I don't know why I came up with this theory in this talk, but I just kind of wanted to learn more about what the tools I do or use actually do on the back end. So that kind of got me to write some of this tooling and stuff like that. So logging of DNS requests is a bit tricky. It's noisy. It's a lot of data. So storage considerations and performance considerations in any organization should be taken into consideration. We can do this again, like it said, at the server or host level. And to do so at the server level, we need to enable Windows DNS Analytical Logging. There's a link here. It's also on my blog. And what that looks like is going into the settings and enabling logging, where I have it checked down there for Microsoft Windows DNS Server Analytical Logging under Event Viewer. And again, once that's running, it's considered an event tracing log, and unfortunately we can't view those live. You can use tools like Microsoft Message Analyzer, which will allow you to view it live, but an event viewer, since it's being actively traced, you won't be able to read it. Yes?
There is if you Google, there are a couple PowerShell scripts that people have written to pull that and write it back to the log to a...
Kind of a loop back to it so you can actually read it?
Right.
That's a good point.
You can read that back, using whatever log beats or something to,
Yep.
or whatever.
Yep. Yeah, we use that here in this example, when log beats, and writing out to that, and using Silk ETW as well. If you played with that, it's pretty cool. So like I said here, we use for our SIM, which is Helk. How many people have used Helk or heard about it or anything like that? It's basically hunting elk stack, written by Cyber War Dog. It is a great tool. It's easy to set up. There's a Docker container for it, and that's what we're going to use here. And then there's a link to Silk ETW down there at the bottom, which allows you to send these logs directly to your SIM as a service or as a standalone application. So here's a link to Helk. Basically just follow the install on the wiki. I'm not going to go through all that. And this is what our network looks like in this simple lab. So we've got a few computers and Helk running, the domain controller on the left, workstation 1 and file server 1, which are forwarding event logs with WinLogBeat to Helk. So on the Helk instance, there's a little bit of setup you have to do. By default, it doesn't listen on port 9200 to 000 if you're using the Docker instance. So you just have to go in there and add a setting to your Helk stack. And that's what this looks like. You just add the little ports, 9200 part at the bottom. Save and close. Now you can rebuild Elasticsearch, follow all this. It's in my blog. I'm not going to go over it. And then next you need to actually set up the post request. So actually at the bottom of this link, the data fields for DNS Analytical Logging are found at that link. And that's what I use to recreate the post request. So this is just arbitrary data that I put in there. So it knows basically just what to listen for. And I am no threat hunter. I'm no elk guru or anything, so if I did something wrong, it's probably wrong, and I have really no idea what I'm doing when it comes to this. So I just kind of put some stuff together, and it worked. And as a hacker, hey, if it works, it's good enough for me. So we got to create an index pattern in the management portal, so it knows what to see from the events. And I'm going to define that as DNS queries, and then set the timestamp filter. And then we can run Silk ETW on our domain controller or DNS server. There is a GUID that's required, and I found that by this TechNet blog, which GUID to use for DNS analytical logging. And we forward that information onto our Helk stack at port 9200 like we opened in the Docker container. So it starts tracing, it starts sending. And what we'll do is we'll do a quick NS lookup within the environment to hackers.com. We see it gets resolved to 14, whatever hackers.com schmuck has that owned. And then we want to check out what that looks like in our Helk stack. So we go in there, we do a quick query for event data queue name. And www.hackers.com, and we can see down there at the bottom that the queue name is hackers.com, and we can see the source for the IP for where it came from. So cool. So we know that somebody queried in our environment for hackers.com, and it came from that computer. So now we can put that to use into detecting actual adversaries. So we're going to use some Canaries. What that looks like is we want to create first a computer object in a real environment. You're going to want these to be enticing. I'm naming it fake file server here just to be, for demo purposes. So we want to name it something, fill in all of the information, description, file server for IT admins, whatever, juicy data, make it look legitimate so that somebody doesn't query it and go, oh, that's a Honey computer account. I'm not gonna look that up. And then we want to create the DNS entries for that. So fake file server points to 10.232.80.07 or 80.7. And then we create a fake user account. So we're doing this because some of the tools that adversaries use, like PowerView and Bloodhound, how many people have heard of those tools, those offensive tool sets? All right, great. So we're all should be pretty close on the same page. And we'll do a quick PowerView overview here in a second. So we set a home folder that points to the fake file server. So what we're saying is when this user logs in, set their home folder to a share on the fake file server. And we can detect when that is queried on the network. So a quick tooling overview, and I would just want to say up front that this is really tool agnostic. This is no dig against PowerView or Bloodhound or anything like that. As this is technique. So when an attacker or an adversary looks up one of your canaries and we're detecting it, doesn't matter what tool they're using, we want to be able to detect which host it came from and things like that. So quick overview, you can find PowerView here. It's great. Defenders can use it to enumerate their stuff and see what's going on in their Active Directory environment. You can do things like look up groups, service principal name accounts, user sessions, and much more, local administrator groups, things like that. You can execute it from disk, in memory, or through a remote access Trojan like PowerShell Empire or any others where you can modularly load PowerShell scripts. So one of the functions in PowerView is find domain user location. What this does is it attempts to find a user's location on the network by enumerating sessions. So I log in and my home folder is mapped to fake file server. If an adversary queries fake file server for sessions, it's going to say, hey, Steve has a session from this computer. So now the adversary knows where I'm logged in and can then attack me if they want. This is under MITRE Attack Framework Technique T1049 for those of you who like to follow MITRE. Even if they use the stealth flag within these tool sets, it's still going to query for those users and see where those file servers are and then query the file server. So it's still going to hit our fake file server. And what that kind of looks like is find domain user location stealth. Let's see all of the results. Al Pacino has a session on headquarters fake FS01, and they're logged in. Their home computer, the computer that they're on right now, is 10.232.80.12. And how do we detect this kind of thing? So, like I said, the find domain user location looks at these kinds of properties: home directory, script path, profile path, and then it attempts to query that server for more information, and we can detect that with DNS and other methods, which we'll get into a little bit later. So what that looks like in our Helk stack is a quick spike. We can see that a fake file server was queried by 10.232.80.11. In two instances, this got, I think, reflected in the network, so it hit it twice. But you can see the spike. This is our canary. Our canary was triggered. This is something that we should have an automated alert on and let us know that, hey, somebody in our environment is looking at these objects that aren't supposed to be looked at. So that's great. DNS is loud. There might be some rogue stuff in your environment that hits your canaries, and you got to filter out that stuff. So how do we kind of add some fidelity to that? How do we enhance that detection? We do so with something that I modified in Packet's SMB server to allow you to put fake data in it, like who's in the local admins group, sessions. You can put, Joe Blow has a session on this computer talking to this file server, so you can make these maps look legitimate. You can make it look like it's a real file server with real people logged into it, when in reality it's all fake data that you're providing to the adversary. So pretty cool stuff, I think. So we just covered some of the deception and detection while logging at the server level. Now we want to kind of move that to the host level. So what I do in this case is I use Sysmon. You can download Sysmon from there, and then I use a configuration by Swift on Security. Most of us are probably following them on Twitter. If you're not, you probably should. Some good stuff. They have a Z alpha version XML, which is configured to enable DNS logging in Sysmon. It's a great place to get started. So what we're going to do is create a few more Canary objects. So fake file server will actually be a Linux box, or it could be a container or something running in your environment. It's going to run our fake SMB server program to respond to session enumeration and local administrator or group enumeration. And then we're going to make another computer object where that actually resides. In this case, we're going to call this one HQ Citrix 01. So we add those objects to Active Directory, like so. Have to add DNS entries for those as well, so that when they're queried, they actually return results to IP to where those things are located. And then we have a user account that points to the fake file server. Same thing. Fake profile could be the logon script path. It could be the home folder. Either way. And I would additionally add in your fake users, add things like their desk phone number, what department they're in, things like that. Make this account look just like all of your other accounts in your environment, so that it doesn't stand out as a honey account. So then the trap, this is how we're going to set it up. So this is the quick how-to. Basically install Impacket, replace Impacket with my Canary server, which is on my GitHub at github.com/reverse/shell/canary server. Basically replace the SMB server, reinstall Impacket, and then place your JSON files, which we'll get to, in there. So the SAMR protocol is basically, there's a good write-up on it here, but it's what allows us to query those local accounts on a box. So this is a quick snippet of what the JSON file looks like. So you're going to put fake data in here, right? This is what you want to give the attacker. So if you want them to think that a real person in your environment is logged in, like a DA is logged into a fake account, so that you're going to tunnel that or funnel that attacker to that location, you can do so. So you can start setting not just detection points, but really pushing the adversaries in the direction that you want them to go. So we have things like time, how long have they been logged into this service, or how long have they had a session on this computer. Idle time, how long has that session been idle? What computer is it coming from? And then what username is logged in. Then we have the user. So this is the SAMR data. This is the session data. So this is domain users is part of local administrators group, right? So for any attacker on the network, finding a computer where domain users has admin rights is a juicy spot to attack. So now we can move laterally, compromise this host, and we're going to be local admin like magic. But in this case, it's fake. So the user doesn't know that, or the attacker doesn't know that. So this is what it looks like. If any of you have used SMB server before from Impacket, it doesn't look any different. I didn't change the code to make it ASCII art and say, oh, cool, Canary server, or anything like that. I just took what they did, left their copyright in there because they're great people and they make great stuff. But I just modified it a little bit with the JSON code and everything like that, so you can return what data you want. And I'm going to do a quick live demo. Hopefully I can figure this out without breaking everything. And maybe. There we go, duplicate. So this is the, let me make this bigger, see it. So this is the SMB server that's going to run on our basically honeypot or trap that's going to be in the environment, Linux box, Docker container, somewhere that you're going to have this hosted. Basically you run that. I use double quotes so that we're not actually sharing the directory. It's just queryable by something coming by looking for sessions and SAMR data. We're running on 192.168.120.129. I have PowerView. I just IEX'd it, downloaded it, and put it into memory on here. And then what I'm going to do first is do a getNet session. So a function in PowerView is say, hey, tell me what sessions are connected to this host. So we're going to do a quick getNet session, fingers crossed, bada bing. Now we have what users are logged into our fake file server. Now this is the data that we provided. So Sean Connery, Will Smith, Colin Firth, Jennifer Aniston, all these famous people are logged in to our fake file server. Now the attacker can be like, ooh, wow, all these people, I know where they're coming from, these other IP addresses. Now I can pivot my attack and go attack them. Well, no, you can't because this is fake data. So we're going to do another one. Clear that. And this is getNet local group member. So this is going to tell us who's a member of the local administrators group. In this case, it's Will Smith. All right. So now if we want admin to this, we can put domain users here if we want. So it's a bit juicier of a target. But we're going to say that Will Smith has local administrator on this host. So if you're going to do this in a real live environment, you're going to set up a few of these traps, some to look like workstations, some to look like servers, just kind of make it look legitimate within your environment, right? So that's a demo, pretty cool, right? Now if I can figure out how to get back to the slide deck without breaking everything. Oh. From current slide. There we go. All right, we're back. So we've completed the demo. Now we're going to actually perform that an attack with Bloodhound or SharpHound. SharpHound is the tool that collects the data for Bloodhound in this. So it's going to do things like that are similar to PowerView's find local admin access and getNet session, find local users, things like that through our Cobalt Strike beacon. So we're going to run Cobalt Strike, and then we're going to run SharpHound with execute assembly. SharpHound is going to run in memory on that whatever host we've initially compromised, and it's going to go around the network and say, where do I have local administrator access? Who are the local admins on every host? What sessions are logged in? Where are the domain administrators logged in? And things like that. So it runs, and then what we see on our honeypot or our Canaries server is that Tiger Woods, so the compromised host had the user Tiger Woods running. So Tiger Woods, we have their hash, whatever their weak password is in your organization. So in this case, it's Tiger Woods is logged into the spiderweb domain. And somebody on that host is querying for SAMR data. So we can see the actual connection to IPC. We can see the SAMR connections come in after that. And we know that there's probably an adversary on that host doing these queries, right? And what that looks like on our map is, let me get this handy pointer that I was handed, and we have the attacker, the adversary. They're coming in through your fancy firewall, the blinky box out there on the border. They fished into your network. They're on headquarters workstation 01, where Tiger Woods is logged into. And then we're going to do things like getNet session. We're going to do things like the DNS query. So when it does that stuff, the first thing it's going to do is, hey, where is this host? What IP address is it at? Now you can detect at DNS level, and then you can also detect with your honeypot down here at the bottom. So when they query these things, It's going to say, oh, now we get to here, and our fake server is running, and the sessions are all going to fake file server. Now we know that when they query fake file server, this user is apparently logged in or has a session on that. And then we know we can go down and query this and see that, ooh, we're local admin on that box. Now we can attack it. Well, you're going to spend all day attacking our Canary server because that's where our fake stuff is running. So those detection points, if you're looking in Helk, we can see the spike in that. I found something very interesting while running this in our demo environments. Not just the fact that you see the first query up there at the top. We can see the process path. The great thing about Sysmon is it tells us which process is actually making the query at the host level. So you can see things like, well, this first one, funny enough, is Windows Defender. Windows Defender says, hey, something is querying, we're going to query that ourselves. Okay, well, we've got Windows, I don't know why it's doing it, but maybe somebody else can tell me. But Windows Defender queries the same thing that you're querying. And then you have your query from Sharphound that's coming in there for HQ Citrix 01. We can see that it's WERF fault.exe because in Cobalt Strike we set that as our spawn to process. So anytime we run post-exploitation with execute assembly or PowerPick or anything like that, it's going to spawn a sacrificial process, talk to it via named pipe, and we can see that detection piece right here. So where fault.exe is trying to query those services on the network. So a bit of an indicator for you to pick up on. So basically in conclusion, that the deception techniques here, are, like I said, are tool agnostic. Any queries for your Canary file systems or your users or anything like that, those DNS queries, those queries to the SAMR server, when you, if you want to modify my code, I haven't quite gotten there yet, because like I said, this is a bit last minute for me, so this code's about half written. I'm going to add some logging capabilities to this, and some things like Slack hooks, Microsoft Teams hooks, stuff like that, so that when you're running your Canary server, when these things are queried, you can get an alert as well as seeing the actual traffic come in and knowing like, okay, well this user from this host is querying my server, which is now I'm feeding it fake data, but why in the first place is Tiger Woods on workstation 01 querying my fake file server and my Canary server? So that's it. Hopefully you guys find this useful. Take this stuff to your test environments or your organization. Put these honey tokens and pots out there and find all the bad. Happy hunting. If you want my tool, it's up there on my GitHub at Reverse Shell and under Canary servers. So thank you for coming. And any question? Yeah, we'll do questions. Clap now. Yay! Thank you. Last talk of the day, all right? We're all tired. So questions? Yes?
So we were talking about filling out the info for your fake users. From your perspective of doing this, and also as a red teamer, if you saw an email address in that fake info, would you be inclined to then pivot and to attack the new user through that fake email, or would you keep going down that the path that you're demonstrating here?
So that's a good question. So he's saying if I'm an attacker and I'm in the environment and I query this stuff and I see an email address, would I then pivot to that user via email, correct? Well, that's quite possible. If I go back to this slide, you can see I'm fished into the organization. So I probably have access to that person's email. Now, if I'm querying and I see other people's email addresses, yes, then I could do an internal phish. I could use this person's credentials to send malicious payloads out now that I know the email scheme inside. So that is a common thing. Once we gain a foothold in any environment, we first pull out all of the email addresses in Active Directory, and yes, these Canary accounts will be part of that.
Right, so then that would be an additional detect that, hey, this fake user just got an email.
Yeah, possibly. Yeah, absolutely. Yeah, you could set that up. That's a good point. Yeah, I didn't even think about that, but sure. You could set up fake accounts and everything all the way down the line so that all these attributes that you're putting in Active Directory are detectable. Sure. Any other questions? Yes, sir. Absolutely. So if you go back to, I have it here, my Twitter account. I have it on my blog. Probably a better place to start would be all the way at the beginning. It's already available on my blog as a complete how-to. So a lot of the stuff that I talked to, I went over it kind of fast. So on my Medium account at Reverse Shell, this is the last blog that I wrote. There's some other good ones. If you guys are red teamers or want to detect people like me, check out that blog for sure. Yep. Any other questions?
That's more of a comment. Do you guys have cases where the defenders weaponize documents or things against you, the attacker?
Okay, so the question is, do we have basically somebody trying to hack back, right?
And hack back, but I was just saying, I give you interesting, you use the file. Okay, so I give you a file share full of interesting documents, all of which have a macro that calls back. So
sure.
As soon as you go to investigate what you've got, have your location.
Yes, that is possible. I have not ran into that personally, but I have seen things like tripwire or other detection pieces like that, that when we're fed fake data on shares, as soon as we touch it or try to download it, somebody's alerted. But that is a great point, and it's something to be wary of if you're an attacker or an adversary, red team, penetration tester. Yes, some things that you open can be basically called back to identify your location. Yeah.
The second thing I kind of have is, you guys check if people are real people when you have compromised.
Yes.
Do you guys check LinkedIn?
Yes.
You check the corporate directory, etc.
Absolutely. Yep. So this kind of thing with the fake honey accounts and stuff like that, you want to make it as real as possible so that the adversary has to do their due diligence, and you're going to catch that first. We're going to catch the DNS lookups first, but then the higher fidelity when they're actually querying those accounts and enumerating that stuff. Yeah, you're going to want to go ahead and make it as realistic as possible, and that could include putting them in the directory or creating LinkedIn accounts for them. Yes. Very good. Any other questions? No? All right, great. Thank you everybody for coming.